Hello students, I am Mrs. Madhavi Salodkar. Today we have to see Unit 3 Lecture 1, some standard discrete probability distributions for Business Statistics second paper, TY/BCom students. So let's see the syllabus. Unit 3 Lecture 1, some standard discrete probability distributions. First distribution is Bernoulli distribution. Probability mass function, mean and variance for Bernoulli distribution. Second distribution is binomial distribution. Probability mass function, mean, variance and additive property of binomial distribution. Some real life situations. Third distribution is Poisson distribution. Probability mass function, mean, variance and additive property. Statement of additive property as well as some real life situations. Moreover, we have to see some examples and problems. So this unit will have 12 lectures. So the first distribution which we are going to see is Bernoulli distribution. Consider an experiment of tossing a coin. Define x is equal to 1 if head turns up and x is equal to 0 if tail turns up. Let P denote the probability of head and Q denote the probability of getting tail. So thus 0 less than P less than 1 and Q is equal to 1 minus P. The probability mass function can be expressed in the following mathematical form as probability x is equal to x is equal to P raised to x Q raised to 1 minus x. X will take only two values 0 and 1 and equal to 0 otherwise. 0 must be less than P. 0 is less than P less than 1 and P plus Q must be equal to 1. This distribution is known as Bernoulli distribution with parameter P. The distribution is applied whenever the experiment results in only two outcomes. One of the outcome is termed as success and is coded as 1. The other outcome is termed as failure and is coded as 0. Such an experiment is called as a Bernoulli trial. Following are some real life situations where Bernoulli distribution is used. First example, sex of a newborn child is recorded in a hospital. Male may be termed as 1 and female may be termed as 0. Second example, atoms in the consignment are classified as defective or non-defective. Third example, seeds are sown. Germination of a seed is termed as success. Now we will see mean of Bernoulli distribution. We know that expected value of x can be defined as summation of xi into pi. So x takes value 0 and 1. So summation of x into p raised to x q raised to 1 minus x, which is equal to 0 into p raised to 0 q raised to 1 plus 1 into p raised to 1 q raised to 0. So expected value of x, the answer is p. To get variance of x, we need expected value of x square, which is nothing but summation xi square pi, which is equal to x square into p raised to x q raised to 1 minus x, which is equal to 0 into p raised to 0 q raised to 1 plus 1 into p raised to 1 q raised to 0. So the answer is p. So variance of x can be derived as expected value of x square minus expected value of x whole square, which is equal to p minus p square. So we can take p common, p into bracket 1 minus p. So variance of x, the answer is p into q. Next distribution is binomial distribution. A discrete random variable x is said to follow a binomial distribution with parameters n and p if its probability mass function is given by probability x is equal to ncx p raised to x q raised to n minus x. The range of x is starting with 0, 1, 2, 3 up to n. and equal to 0 otherwise. Notation: X follows binomial distribution with parameters n and p, where n and p are the parameters. N is nothing but number of trials and p is probability of success. P plus q is equal to 1. Mean of binomial distribution is denoted by expected value of x is equal to np, and variance of binomial distribution is given by variance of x is equal to npq. Real life examples of binomial random variable. First example: number of defective atoms in a lot of n atoms produced by a machine. Second real life situation: number of male births in hospital. Third real life situation: number of seeds germinated in a row of n planted seeds. See the example. An accountant has to audit 24 accounts of a firm. 16 of these are of highly valued customers. If the accountant selects 4 at random, what is the probability that he chooses at least one highly valued account? Now first step is to recognize the success. Getting question part is my success. Getting highly valued account is the question part. So we will define x as let x denote the number of highly valued account selected. So therefore x follows binomial distribution with n is equal to 4, and probability of getting highly valued account is 16 upon 24, which is equal to 2 upon 3, which can be written as 0.67. The probability mass function of binomial distribution is given by probability x is equal to ncx p raised to x q raised to n minus x. X range starts with 0, 1, 2, 3 up to n and equal to 0 otherwise. Now in the next step we will replace the parameters. So we will rewrite the probability mass function as probability x is equal to 4cx 0.67 raised to x 0.33 raised to 4 minus x. If p is 0.67, q is 1 minus p. So q value becomes 1 minus 0.67, so 0.33. We want to find probability x greater than or equal to 1, which is equal to 1 minus probability x is equal to 0. Now we will calculate probability x is equal to 0 as 4c0, 0.67 raised to 0 and 0.33 raised to 4. So 4c0 the value is 1, 0.67 raised to 0 the value is 1. So we have to calculate 0.33 raised to 4. So the answer is 0.012340. But we want to find the probability of x greater than or equal to 1, which is given as 1 minus 0.012340. So the answer is 0.987659. Next example. A student prepares for the examination by studying a set of 10 problems. He can work 7 of the 10. If the professor chooses randomly 5 of the 10 problems for the examination, what is the probability that the student can work at least 4 of them? Now student working a problem is my success because that is the question part. So we will define x accordingly as let x denote number of problems a student can work. According to the information given, x follows binomial distribution with n is equal to 5 and probability of success as 7 upon 10, which is equal to 0.7. In the next step, we will write the probability mass function of binomial distribution is given by probability x is equal to ncx p raised to x q raised to n minus x. The range of x is starting with 0, 1, 2, 3 up to n and equal to 0 otherwise. We will rewrite the probability mass function by replacing the parameters. Probability x is equal to 5cx 0.7 raised to x and 0.3 raised to 7 minus x. We want to calculate probability x greater than or equal to 4. So that is nothing but probability x is equal to 4 plus probability x is equal to 5. So the values are probability x is equal to 4 is equal to 5c4, 0.7 raised to 4 and 0.3 raised to 5 minus 4. Probability x is equal to 5, the value is 5c5, 0.7 raised to 5 and 0.3 raised to 0. So probability x is equal to 4 can be calculated as 5c4, 0.7 raised to 4, 0.3 raised to 1, which is equal to 5 into 0.2401 into 0.3. So the answer is 0.36015, and probability x is equal to 5 can be calculated as 5c5, 0.7 raised to 5, 0.3 raised to 0. So the answer is 1 into 0.16807 into 1. So the final answer becomes 0.16807. Now we want to find probability x greater than or equal to 4. So it becomes probability x is equal to 4 plus probability x is equal to 5. So we will add both the probabilities as 0.36015 plus 0.16807. So the answer becomes 0.52822. Next example. An automobile company claims that 1 in 10 automobile accidents is due to driver's fatigue. What is the probability that at least 3 of 5 automobile accidents are due to driver fatigue? So let X denote number of accidents due to driver fatigue. So parameters of binomial distribution are X follows binomial with n is equal to 5 and p is equal to 1 upon 10. So value of p is equal to 0.1. Then probability mass function of binomial distribution is given by probability x is equal to ncx p raised to x q raised to n minus x, which x range is starting with 0, 1, 2, 3 up to n and equal to 0 otherwise. Now we will rewrite the probability mass function again by replacing the parameters. So probability x is equal to 5cx, 0.1 raised to x and 0.7 raised to 5 minus x. We have to calculate probability x greater than or equal to 3, which is nothing but probability x is equal to 3 plus probability x is equal to 4 plus probability x is equal to 5. Let's see how to calculate probability x is equal to 3. Is given by 5c3, 0.1 raised to 3 and 0.9 raised to 5 minus 3. So 5c3 can be written as 5 factorial upon 3 factorial into 2 factorial into 0.1 raised to 3 into 0.9 raised to 2. Now 5 factorial can be written as 5 into 4 into 3 factorial upon 3 factorial is there into 2. So 3 factorial cancels with 3 factorial and 2 ones are 2 2s. So 5c3 the value becomes 10. And 0.1 raised to 3 we can write this value as 0.001 into 0.81. So the answer becomes 0.0081. Then 5c4, probability x is equal to 4 is equal to 5c4, 0.1 raised to 4 and 0.9 raised to 5 minus 4. So we can write this as factorial 5 upon factorial 4 into factorial 1 into 0.1 raised to 4 into 0.9 raised to 1. So 5c4 the value is 5, 0.1 raised to 4 the value becomes 0.001 into 0.9. So the final answer is 0.00045. Then we will calculate probability x is equal to 5 as 5c5, 0.1 raised to 5 and 0.9 raised to 0. So the answer becomes 1 into 0.00001 into 1. So that is nothing but 0.00001. Therefore, probability x greater than or equal to 3 can be written as 0.0081 plus 0.00045 plus 0.00001. So the answer is 0.00856. Next example. An oil exploration firm finds that 5% of the test wells it drills yield a deposit of natural gas. If it drills 6 wells, find the probability that at least one well will yield gas. So the well yielding gas is my success. So we will define x accordingly as let x denote number of wells that will yield gas. So x follows binomial with n is equal to 6 and p is equal to 0.05. The probability mass function of binomial distribution is given by probability x is equal to ncx p raised to x q raised to n minus x. X range starts with 0, 1, 2, 3 up to n and equal to 0 otherwise. Then we will rewrite the probability mass function by replacing the parameters as probability x is equal to 6cx 0.05 raised to x 0.95 raised to 6 minus 6. And we want at least one well. So probability x greater than or equal to 0, greater than or equal to 1 can be written as 1 minus probability x is equal to 0. So probability x is equal to 0 can be calculated as 6c0 0.05 raised to 0 and 0.95 raised to 6. So 6c0 the answer is 1. 0.05 raised to 0 is the answer is also 1. So 0.95 raised to 6 the value becomes 0.73509189. But we want to have probability x greater than or equal to 1, which can be written as 1 minus 0.73509189. So the answer becomes 0.264908109. Next example. The probability that a man aged 45 years will die within a year is 0.012. What is the probability that out of 10 such men, at least 9 will reach their 46th birthday? Now reaching 46th birthday is the success because the question part is my success. It means the man will not die becomes my success. So let x denote number of 45 years aged men reaching their 46th birthday. So x follows binomial with n is equal to 10 and death probability is given. So p will be 1 minus 0.012 which is equal to 0.988. So x follows binomial with n is equal to 10 and p is equal to 0.988. The probability mass function of binomial distribution is given by probability x is equal to ncx p raised to x q raised to n minus x. X value, the range of x is starting with 0 and it is up to n and equal to 0 otherwise. So probability x is equal to 10cx 0.988 raised to x 0.012 raised to 10 minus x. We want at least 9. So probability x greater than or equal to 9 is the requirement, which is nothing but probability x is equal to 9 plus probability x is equal to 10. So probability x is equal to 9 can be calculated as 10c9 0.988 raised to 9 0.012 raised to 1. So 10c9 the value is 10, 0.988 raised to 9 the value is 0.897041 into 0.012. If you take the product, the answer is 0.107644971. Next part of the problem, probability x is equal to 10 can be calculated as 10c10 0.988 raised to 10 0.012 raised to 0. So 10c10 the value is 1, 0.012 raised to 0 the value is 1, 0.988 raised to 10 the value is 0.886276. So the answer becomes 0.886276. So probability x greater than or equal to 9 can be considered as 0.107644971 plus 0.886276. So the final answer is 0.9939219.